Hello friends, welcome to my channel. Let's have a look at another linked list problem. Problem 369, plus 1 in linked list. So in this video, we're going to practice some basic operations in linked list abstract data type. So first, I'll read through the statement of the problem, and then we do the analysis, and finally we share the code. First, let's look at the statement. So given a non-negative integer represented as a linked list of digits, so plus 1 to the integer, so that's our task. So the digits are stored such that the most significant digit is at the head of the list. So here is two examples. So example 2 is sort of trivial, and in example 1, so we have 1, 2, 3 representing the number 123. So if we add 1, we're going to have a linked list representing the number 124. So let's also look at the additional constraints or assumptions for this problem. First, the number of nodes in the linked list is in the range 1 and 100. And the digit value is in between 0 and 9. And the number represented by the linked list does not contain leading zeros except for the 0 itself. So that's the main statement of the problem, so which is actually very short. So now let's look at the analysis and the method. So here we are going to practice some basic operations in linked list. So the procedure for this problem actually is the following. First, we are going to do a reverse. So we reverse the linked list so that the least significant element will be at the very beginning or at the head. And then we add 1 from the least significant digit after doing the reverse. So currently the least significant digits are the head now. So and then after we add the 1, so we reverse the result in step 2 and return the result. So here is some walkthroughs. So for example, if a number is 129, so that's the linked list 129. And then what we are going to do is that we reverse it to get 9 to 1. And then we add 0. So if we add 0, so 0 plus 9 will be 10. So we get this digit is a 0. And then we have a 3. 3 equals 2 plus 1, right? We have 0, 3, 1. And then we do the reverse, we get 130. So this is one example. So in this case, the result linked list have the same length as the original linked list. So let's look at another example. So let's see, the head is representing this linked list, that is 9, 9, 9. So if we do the reverse, actually it's still 9, 9, 9. And then if we add 1, so actually we get 0, 0, 0, and 1. So after we do the reverse, we get a linked list representing the number 1000. So in this case, so the linked list has an extra node added. So the length is the original linked list length plus 1. So this case is to be noticed. So with that said, we can carry out the procedure, that is the 3 steps specified above. So we're going to split the code exactly into 3 parts. So the first part is going to write a reverse function, reverse hyperfunction. So for this, I'm going to define this as reverse. So the reverse accepts a linked list. So let's see its head. So in order to do the reverse, we are going to introduce a previous variable called none. And then we initialize a current, which pointing to the current head. And then it's basically a while loop. So while current. So what we are going to do is that we first retrieve the current next. The current next is current next. And then we set the current next to be the previous, right? So this also breaks the link of the current to its next, right? So and then we reset the previous to be the current, and the current to be the current next we have retrieved. So it's current next. So then afterwards we just need to return previous. So this way, actually, once we input a linked list head, we can get a reversed linked list. So this is the step 1. And the second one, so we're going to write an add 1 hyperfunction. So for this, actually, notice that we are dealing with linked list. So let's see add. So the add function will accept a linked list, and then because in this case we need to consider the case like example 1. Sometimes we have a carry. So we're going to specify a previous variable, initially none, and then the current will be the head, and the number we are going to add is 1, right? Let's call it R. And then we are going to look at the while loop, while current. So then what we are going to do is to check if current value plus this R is less than 10. So if it's less than 10, we just add 1 to the current value, and then we can stop, right? So the current value incremented by 1, and then we're going to return the head. So this is the one case. Another case is that the current value plus R equals 10. So in this case, so we are going to have a carry, and then we need to consider the next digit. So in this case, we are going to set the current value to be 0, right? And then we set the previous to be current, and then the current to be current next, right? So in this case, we are going to add 1 to the next current. So that's R here, right? So that's the case. So if in between we have returned head, everything is okay. It's corresponding to the case that the resulted linked list have the same length as the original linked list. But if we have a situation like 999, so we need to add one more node, that is previous next to be list node 1. So you can think of this line and compare it with here, right? So that's the case. So in this case, we're going to return head specifically. So that's the hyper function for this add 1. So both the step 1 and step 2 are actually very basic operations in linked list. And then the third one is the call the functions and do the return. So in this case, first we're going to reverse the linked list. So reversed, so let's reversed equals reverse head, and then we call add 1 to the reversed. So let's call it preparation equals add, so reversed. And then what we're going to do is that we return the reverse of the list get. It's called preparation. So that's all about it for this specific solution. Let's first do a special case check. Yeah, it passes this special case 999. So let's do a generic case check. Yeah, it passes all the generic cases. So let's give a quick overview of this, or summary of this code or this solution. So in this code, actually, we did two basic operations for a linked list. First, we do the reverse operation. So that is the part 1, reverse hyperfunction. And in the second part, we're doing the add 1 operation using a hyperfunction. So after the two parts, part 1 and part 2, so we just need to call the functions and to do the return. So that is step 3. We first do the reverse so that we can easily add 1, and then we return the reverse again. That is the reverse of the reverse. So with that said, I guess that's about it for this video. Thank you very much.